Imagine you're at a game, and the stadium screen shows a game-winning goal in flawless 4K, right? But the deafening roar of the crowd plays like half a second late.
Oh, pure chaos.
Right, total disaster. Well, today we're taking a deep dive into the invisible hardware that prevents that exact scenario. We're looking at a highly technical product catalog page from HDTV Supply, and our mission is to decode the AJA 12G-AMA.
Yeah, which is a 4-channel balanced audio embedder and disembedder.
Exactly. And, you might be wondering why anyone would pay almost $1,300 for a box that essentially just manages cables.
Okay.
Okay, let's unpack this, because what this piece of tech actually does behind the scenes is incredibly complex.
It really is. I mean, the primary job of this device is to either separate or combine analog audio and a high-quality video signal, but doing it without ruining the picture.
Right.
In a professional live broadcast, that pristine 4K video from the camera and the audio, they rarely take the exact same path.
Ah, gotcha. So it's essentially a high-tech zipper. It either strips the audio and video apart so you can mess with them, or it zips them perfectly back together. But why not just keep them together from the start?
Well, what's fascinating here is that producers need to pull the audio, route it to a mixing board, maybe add commentator feeds, and monitor it. And they have to do all of that while keeping the flawless video feed completely untouched.
Okay, but mechanically, how does it actually shove both signals into one single cable when it zips them back together?
That is where the embedding process is so clever. Video signals aren't just continuous solid blocks of data. They actually have these tiny blank spaces between the frames.
Wait, really? Blank spaces?
Yeah, and this embedder acts almost like a data smuggler. It packs the 4 channels of analog audio directly into those microscopic blank spaces, so everything travels down a single cable perfectly in sync.
Wow. But separating them gives producers total control, right? But it must create a massive logistical problem. Once you pull them apart, you have to move massive amounts of uncompressed 4K data across the studio to sync them back up.
Oh, absolutely.
The specs say this uses 12G-SDI. I'm guessing that is basically a massive digital pipe wide enough to shove all that 4K video through.
Exactly. 12G-SDI pushes 12 gigabits of data per second. To give you an idea of the bandwidth, a standard heavy-duty copper coax cable can carry that massive speed for about 65 meters. But the device also offers single-length fiber optic input and output models with LC and ST connectors.
So what does this all mean? I mean, 65 meters of coax cable is over 200 feet. For a $1,300 box, who is actually exceeding that distance to the point where they absolutely need a fiber optic upgrade.
It really comes down to the environment. 200 feet is nothing in a sprawling NFL stadium, or a massive multi-level broadcast facility.
Oh, I guess that makes sense.
Plus, when you run copper cables through a stadium packed with thousands of radiating cell phones, huge power arrays and radio frequencies.
Will interfere.
Exactly. That copper acts like a giant antenna for electromagnetic interference.
Wow.
Fiber optics transmit data using pure light, so they ignore all of that electrical noise entirely. If you look at the catalog context, HDTV Supply is catering to massive installations, like sports bars with 160 TVs.
That's a lot of screens.
Yeah, and in those environments, light is literally the only way to guarantee the signal survives the trip.
Okay, but here's where it gets really interesting to me. We are talking about transmitting uncompressed 4K video over beams of light.
Right.
But to actually operate this cutting-edge device, it relies on physical, chunky XLR audio cables, and it comes in the supplied breakout cable, plus it has old-school mechanical DIP switches on the outside. Why pair futuristic fiber optics with hardware straight out of the 1980s?
Well, if we connect this to the bigger picture, it's about what broadcast professionals demand, and that is absolute physical reliability. In live television, a dropped frame or a software crash costs thousands of dollars a second.
Ah, so a physical switch is safer.
Exactly. A mechanical DIP switch doesn't randomly crash or require a firmware update. And an XLR cable clicks into place and literally locks. They need that tactile, fail-safe hardware.
But it does have a USB port too, right?
Yeah, uses AJA mini-config software for Mac and PC if you want granular digital control. So you get that fail-safe hardware just as much as you get modern software flexibility.
It really is the unsung hero of live TV. Just a physical box sitting in a rack somewhere, flawlessly ripping apart and stitching together uncompressed 4K data so our living room viewing experience stays perfectly synced.
It really is.
But, looking at the broader catalog, we see hints of emerging 8K products and massive AV over IP digital networks, which leaves you with a pretty provocative question to think about. As broadcasts shift entirely to networked, software-based routing, will the industry eventually outgrow these physical hardware embedders entirely?
That's the big question.
Yeah. Or no matter how advanced the digital cloud gets, will we always need a physical zipper to keep our audio and video tied together? Something to chew on.